Hello guys, we're going to be talking about dynamic routing protocols. A structure that we have in the graphic, and we have besides that two different kind of dynamic routing protocol. Interior Gateway Protocol, IGP, and Stereo Gateway Protocol, EGP. When the Stereo Gateway Protocol is going to be Path Vector Routing Protocol, Link State Routing Protocol, and Distant Vector Routing Protocol. We're going to be talking a little bit deeper in that in a couple seconds. Introduction to routing protocols. We're going to be giving a description of the dynamic routing protocols that we have. For example, in this graphic, we are going to see the two different kind of routing protocols, the dynamic one and the static one. The dynamic one is the one that we're going to be focused on. Why? Because it gives an advantage, especially when there is a converse time. Converse time means that when we need to find a really fast alternative to get a reroute option where we can get information and we can hook up to another one of the routers. As you know, routing protocols are used to pass information about the structure of the network between routers. Cisco routers support the following IP routing protocols: RIP version 1 and 2, RIP NG that stands for new generation and is used for IPv6, IGRP, we don't use that much, IEGRP, that's the one that we're gonna see more often, ISIS, that we are barely gonna see that, and it doesn't stand for the terrorist group, OSPF, and BGP. OSPF we're gonna use badly, and BGP we are not gonna see that very often, but it's a very important protocol because it carries one of the most important stuff in the world nowadays, the internet. So this session we're gonna compare the different routing protocols and call out key difference between them. So one of the major questions that we're gonna ask in selecting a different protocol, what is the big question that we're gonna see, that we're gonna answer ourselves when we are gonna choose between OSPF, IEGRP, and RIP? You know what it is, guys? Where will it run? We need to know where will it run, but first we need to understand very well two different concepts: IGP and EGP, Interrogate Protocol and Interrogate Protocol. Before talking about Interrogate Protocol and Interrogate Protocol, we need to understand the term autonomous system. Autonomous system is an internet under the control of a single organization. For example, an internal network of a company uh, can have a autonomous system. I am using my ISP Comcast, and probably Comcast is going to be using autonomous system as well. So, interrogate protocol used within a single AS, a single autonomous system, and a protocol that we are going to be discussing will be IGP. There is an interrogate protocol used to route between different autonomous systems, and the only interrogate protocol that we are going to see is BGP. We're going to barely discuss about BGP right now, guys, to be very honest. We're going to focus on RIP, but mostly on OSPF and EGRP. So going back into that issue, let's talk about the different router protocols. The different router protocols that we have is path vector. Then, as we say, if EGP to connect between different IS, the distant vector protocol, RIP and IGRP, but mostly it's gonna be IGRP. IGRP we're gonna barely touch. We are gonna see IEGRP, the Advanced Distant Better Protocol, and RRP V1, V2, and AG. From the list state protocol, we have two options, two flavors, OSPF and ISIS. No, it's not. ISIS doesn't stand for the terrorist group, guys. But we are going to be focused on OSPF and IEGRP. Got it? Yes. So I want you to physically visualize what I'm talking about. Remember when we were talking about the AS, the autonomous system. We have autonomous system over here 100. We have autonomous system over here 200. This is how we identify the different autonomous systems. We have inside of each one of autonomous systems, we can have RIP, IEGRP, and or OSPF. It can happen on the other autonomous system as well. But the only one that can connect both of it is the external gateway protocol. The only one that we have is BGP. So we're gonna see a graphic over here of the different routing protocols and the difference between dynamic and static. That is basically how fast they can converge when there is some issue in the network. For example, a link failed, and it needs to find a very fast way to get another link that it can connect two different networks. So when we're talking about routing protocols, what are the issues that we're going to find? Routing protocols need to be configured manually. That means, for example, you have a Cisco router is very different than the one that you can buy. I don't know, at your local hardware store when you only connect it and you leave. You need to connect that router very specifically with a very specific configuration of what you are gonna need from the interface. What kind of routing protocols are you gonna choose? The different path that you wanna take, the different configuration, etc., etc. That's one thing. Second thing must be configured on all routers that need a route. That means if you have 10 routers, you're gonna need to be configure those 10 routers at once, not only one and whatever. You need to the routing protocols do not account for link failure easily. And now we're going back talking about convergence. In case that one of there is a link failure, it needs to find out a very fast way through another path to get from router A to router B. Every new network requires a new static route. Well, that's obvious. Directly connected routers don't provide full connectivity in large networks. Directly connected routes only work in a very small networks. So this is something that works a little bit better with dynamic protocols, as we mentioned before. Best route should directly reflect network performance. When we are talking about network performance, we're gonna get deeper into that in a couple seconds. We are talking about the fastest way that the routers can get from one place to another place, another router in your personal network. Summarizing several routes as a single route would reduce overhead. When we are talking about reducing overhead, we are talking about when several of the routing protocols can have issues with carrying the whole IP table, IP route tables, and everything that works with that. But we are going to be talking about a little bit subnetting that applies mostly with RIP version 1 and RIP version 2. So let's talk about the classful and classless RP routing protocols. Classful routing protocols assume that every classful network is contiguous. The network is all the routers are one by the side of the other. They do not care about subnet mask information because they assume that everyone is on the same subnet mask, and they automatically summarize routes between major networks. The word over here is automatically. That's the most important stuff. RIPv1 is the only one classful that routing protocol that we are gonna barely see. Classless routing protocol. Classless allow for fine-grained subnetting. We're gonna be talking deeply into that in the future. We're gonna only be touching and mention that very mass information that doesn't happen in the classful. The only classful routing protocol support VLSM. That stands for variable length subnet masking. It's the same thing as the cider subnetting, and it's an efficient way of subnetting in case that some of you guys don't understand. The only classful routing protocols that allow manual summarization. Remember, the name over here is manual, and it's very different from automatically that we saw on the classful one. And most do automatically summarize between major networks like RRPv2, OSPF, or IEGRP, which are classless. We can see over here another way so people can understand the different IGPs and EGPs of the different distant vector link state routing protocols and path vector routing protocols. Got it? Yes. Administrative distance. Cisco routers are capable of supporting several IP routing protocols concurrently. Yes, and it applies way much more when we have redistribution, and we're gonna see that in a couple seconds. When identical prefixes are discovered from two or more separate sources, administrative distance (AD) is used to discriminate between the paths. Administrative distance or AD is a poor choice for words. True worthiness is a better name. Rather use path with the lower AD. And I want you to remember this guy. Rather use path with the lower AD, administrative distance. The numbers on the right is going to be the administrative distance that we are going to see. And I don't want you to get very confused with that. I want you that you remember that the most important administrative distance that you're going to see is the RP 120 administrative distance. The OSPF, the administrative distance is 110, and the IEGRP, I mean internal IEGRP is gonna be 90. So remember as well the static route that is not gonna be the number one, and we're gonna see that over and over in a lot of different scenarios that we're gonna face in the future. Metric. Each routing protocol has its own way to determine the best path to a network. Metric, the best path to a network. So when we are talking about RIP protocol, the best path that they use is hop account. Remember that hop account, for example, it use a maximum path of 15. A maximum path of 15, when you get to 16, is considered infinite. RIP as a distant vector, it needs to advertise at regular intervals the whole routing table. And we're gonna see that in a very close future. And that makes everything, the drawback is that make it very inefficient and slow. When we are talking about OSPF, we're talking about some inverse of bandwidth that we are talking about cost. And when we are talking about IEGRP, we are talking about bandwidth and delay. And each metric has certain advantage or disadvantage. But for example, when we were talking about IEGRP, then besides bandwidth and delay, it has several other factors as well. For example, when we are talking about redistribution, for example, this is part of my personal lab that I have at home. At home, I have over here, you see the red cable and the dark blue cable. One stands for FA00 and FA01, two different kind of interface. It can have a redistribution to one of the routers that is on the top of that very specific router. But one could be carrying OSPF on one cable, and one could be carrying on the other interface EIGRP. So when we are talking about bandwidth and delay, we're talking about this factor over here. I want you that you focus over here. Then you have the bandwidth of 1,544 bits and a delay of 20,000. But there is also, as you could see over there, NTU, that stands for maximum transmission unit, reliability, and loads. This happens in IEGRP. Types of IGP. We're talking about distant vector. When we are talking about distant vector, we're talking about a, a router that sends a full copy of the routing table to the attached neighbor. Router knows only distant hops and vectors the next hop. The metric is the hop account. As I mentioned before, in the RIP, the maximum number that it can send of hops is going to be 15, and 16 is infinite. Routing Information Protocol, RIP, is the only distance that we are going to discuss. With distant vector, we need to start thinking about converge. That is the time that they will need all the routers to obey the routing tables. But there are potentials for router loops. Distant vector use two router loops prevention: split horizon and poison reverse. Split horizon is when a router learns on one interface from being advertised back on the same interface. Poison reverse means that a router receives an interface being advertised on the same interface. Link state. Router knows the state of all these links interface in the internet network, and select the best path. Allows routers to build a topology map. It's a link state advertisement. LSA. Open Shorter Path First, or OSPF, is the only link state protocols that we are going to discuss. We're going to be talking about enhanced distant vector, balanced hybrid, that is very specifically IEGRP. The routers use no topology for neighbors route, not all routers, and select the best path. Use as a metric bandwidth and delay, as you saw, and other parameters like reliability, load, and NTU in the IEGRP. That was the example that I showed you previously, guys. IGP stands for Border Gateway Protocol, the routing protocol that connects to the internet. And that's very important because of that. But we are gonna barely see only a couple of stuff about BGP. The SAT path packet takes to reach certain destination. That's gonna be the metric over there. So we're gonna be talking about a little bit about RIP. You could see over here, in case that there is one failure, it takes time to converge all that routing table, and it takes time to update the routing table when it moves from all the information through one of the router to the other one. We're gonna see over here as well the OSPF, and Basically, the first one that you're gonna see is the backbone area. Then call this the stop. After that come totally stop it or whatever. Not totally stop it. So it's kind of hierarchical, a kind of protocol. We're gonna be talking about that a little bit later, but I want you to make sure that you understand how it is structured. ABI, the area border routers over here, and how they can connect from, for example, from router number 3 to router number 1, and how they're gonna be connected. And over here, we're gonna see IGRP tables. IEGRP tables carry 3 tables. One is the neighbor table, one is a topology table, and the other one is the routing table, guys. The difference between IPv6 and OSPF. Well, basically IRP v2 or IRP NG stands for new generation, and the other one is the OSPF. New generation is we're talking about IPv6. It was, as you could see, established in different time, 193, 198 is RIP. RIP is a distant vector, the other one is link state. Administrative distance that you already know is 120 and the other one is 110. Maximum number of counts is 15. Remember that we just mentioned that after 16 is infinite and the other one have no limit. Network size, RRP was designed for a small network, and OSPF for design it could be small or large, and so it doesn't have any issue with that. 2 different kind of algorithm to calculate everything. The convergence time is slow. That's a drawback that RIP have, and OSPF is kind of fast. We're gonna see as well the BLSN that we just mentioned that is available on RIPv2, but it's not available RPv1. Then we're talking about the side of the optimal subnet masking, and on OSPF is available with the running couple of days in 30 seconds, the bandwidth usage, the areas that or boundaries that it doesn't use. But so you could see in the graph, it has area 1, area 2, area 3, or whatever. And the backbone area, there's totally stubby, not so stubby, whatever. And we're going to get very deep into that in the future. The metric that we were talking about, hop count, and on the OSPF, we have the cost. Difference between OSPF and IEGRP. Well, I just saw this stuff, guys, but I just want to mention, I don't want to be count on this 100%. But I want to tell you a couple of stuff about this stuff. For example, between OSPF and IEGRP. OSPF is optimal for large mesh. I mean, when you have a lot of different areas and a lot of different stuff and a lot of routers spread all over the place, and you want to have a connection from the backbone to the other ones and to different kind of routers that have a lot of different kind of scenarios. Or EIGRP is a little bit better when it's hop and spoke. Hop, one router that is sending information directly to 2, 3, 4, whatever, any kind of routers on the same direction, and it's gonna be a more clear configuration. OSPF is saying that it's more flat, and the IEGRP say that it's hierarchical. I disagree with that. OSPF, the configuration is more complex, and IEGRP is a little bit more simple. And we're gonna check that in the future, how to do the configuration of both of them. We're gonna see a little bit different over here about OSPF and IGRP. We're gonna see that it say that I have some disagreements. Say most popular IGP in the world. I don't know about that because now it say that it's less popular. That is not completely true because since 2013 it was it says that it was a private routing protocol from Cisco and now it's open through other vendors as well. So for in the OSPF, it's saying it's a fast convergence, loop free, and EIGRP says have a dual algorithm to use to query that could spread out on the whole network. The topology is it can be hierarchical, as we mentioned before in this place over here. Then I disagree because we have different areas: area 0, 1, 2, stubby, not so stubby, blah blah blah. That's a very hierarchical area, and IGERP cannot be a hierarchical network. Supported for new technology, support OSPF TE, and it doesn't support TE. So over here, we're gonna see a lot of different stuff to summarize everything that we just saw. That is the PAM vector, link state, distance vector in each one of them, and we're gonna see that over here, the protocol type of each one. We already talked about that. Which one is proprietary? It was saying that IEGRP was a proprietary of them, not anymore, because it's 2013. It's not a co-proprietary of those. The function, the EGP, IGP, or whatever, the ports where they are flowing through, the updates, how they are triggered, incremental, triggered by unicast, multicast. We're going to be jumping in unicast and multicast in a close future. The metric that they're going to be having, and this is the way that they configure each one of them. You don't have to memorize that. RP, hop account maximum of 15, as we say. BLSM, that is basically it's either subnetting, and BGP is classless, and the only place that is not classless, as we mentioned, is in RIP, as we mentioned before. Summarization, what happened each one of them, and you could see over here a small difference, and the authentication they can use, and the default distance, that is 110, 100, 120, 120. So guys, you saw the summary of routing protocols. I hope that you like it, and thank you very much for watching and joining me in this lecture. Have an excellent day, guys, and please share and talk about it.